Hi, this time we're going to talk about expanding with two sets of brackets. Last time we looked at just one, now we're going to look at two and they're next to each other. So obviously we know that no sign means times, so what we're saying is this whole thing needs to multiply by this whole thing. And we're going to use a little acronym called FOIL. So FOIL stands for first, outside, inside, last, right? First, outside, inside, last. So that's the order in which we're going to multiply things. And then we're going to collect any like terms that we have at the end. I'll give you a demonstration as to why this works in a minute, but let's just practice the method. So the first thing we're going to do is multiply the first terms. So the first term in each sets of brackets. So I'm going to do x times x, which is obviously x squared. Then I'm going to do the outside two terms. So the ones on the outside. Whoops, that should have gone all the way over there. That's a great drawing. So x times 4 is just 4x. Then I'm going to do the inside next. So the inside two terms, 3 times x is 3x. And then I'm going to do the last two terms. So 3 times 4 is 12. And then I'm going to have a look and see what matches. Well, my inner two terms are like terms, so they can go together. So x squared plus 7x plus 12. Now none of these match. There's nothing else I can do. I have to leave it there. So I'm just going to show you why it works like that. So you can't just do, so one of the common mistakes people will make is not doing all four of these things. So if I was going to do, let's put some numbers in here. So let's make x2. So 2 plus 3 and 2 plus 4. Okay, so this would be 5 times 6, which is 30. So then if I use this method, let's pretend that all of these are x's. So actually this would be 2 squared plus 7 times 2 plus 12. Let's see what that does. 2 squared is 4, plus 7 times 2 is 14, plus 12. 4 plus 14 is 18, 18 plus 12 is 30. See how it works? So this is what we do if we have algebra, right? Obviously you would just do it this way if you had numbers, but we're dealing with algebra now. All right, so same thing for the next one. This time we have a minus sign though, so it's going to change it a little. So we're going to start with our first two terms. So x times x is x squared. Then the outside two terms, so x times negative 6 this time. Why do my pens always run out when I'm in the middle of your videos? Oh my goodness, this is so irritating. Wow, okay. Let's see if, all right, let's just swap to this blue. All right, so x times negative 6 is going to be minus 6x. Then I'm going to do the inside term, so 5 times x is 5x, and then the last terms is 5 times negative 6, so that gives me minus 30. Again, I've got my two like terms in the middle here that I can put together. So I have x squared, and it's minus 6 plus 5, which is just negative 1, minus 30. All right, same thing for the next one. This time the negative's in the first half of the brackets instead of the second, but it makes absolutely no difference. It's the same. So x times x is x squared. X times 10 is 10x. Negative 7 times x is minus 7x. And then negative 7 times 10 is negative 70. So again, I put my two like terms together. So x squared and then 10 minus 7 is just 3x and then minus 70. Now I'm going to give you a little bit of a shortcut here. I want you to practice this method. FOIL is the way that we want to do things. But when we reverse this process later in the chapter, this is a really good hint to know. So if you see here, these two terms are important. So these two numbers are important. So you'll see that this number is always when you add these two numbers together. So 3 plus 4 is 7. And this number is always when you multiply them together. 3 times 4 is 12. Same thing happens here. 5 plus negative 6 is negative 1. And 5 times negative 6 is negative 30. Because that's really what we're doing here, right? Adding these together and then multiplying for this one. Same thing here. Negative 7 plus 10 is 3. And negative 7 times 10 is negative 70. So that's a really good thing to keep in your mind for when we reverse this process, that these two numbers always add to the middle term and multiply to the last term. Now that changes if there's a number in front of one of these x's, but for now there's not, so don't worry about that. All right, so back over here. This time I have two negative signs, so I need to watch my signs again. So The first bit doesn't change. Let's go back to blue. It's a bit easier to see. So x times x is x squared. It doesn't look like a squared. X times negative 6 is minus 6x. Negative 1 times x is just minus x. And now I have negative 1 times negative 6, so the two negatives will cancel each other out, and I have plus 6. So then I still have x squared, and now I need to watch my negative signs. So negative 6 minus 1 is negative 7x, and then plus 6. And again, negative 1 plus negative 6 is negative 7. Negative 1 times negative 6 is 6. All right, so now it's looking a little bit different. So now I only have letters involved. So I'm going to do the same thing, but I'm not really going to be able to, it's just going to look different, right? All letters. So same thing. So I have m squared. M times negative n is minus mn. Then I have n times m, so plus mn. Remember what I said before about writing things in alphabetical order? So even though it was n times m, I'm still going to write my letters in alphabetical order. Then I have n times negative n, so that would be minus n squared. Now this is a special pattern called DOPS. So this stands for difference of perfect squares. We will talk more about this later, but this is a special pattern that's good to recognize. When the brackets are exactly the same, but the signs are different, what's going to happen is these two terms are going to cancel each other out, right? Because I've got one negative and one positive, and that just is 0. It doesn't matter what they equal. Anything minus itself is 0. So then I'm going to end up with m squared minus n squared. So see how I lose a term? When you've got DOPS, you should only end up with 2 terms at the end. That's why it's called difference of perfect squares, because these are both perfect squared numbers and the difference between them, right? So you can see that this is exactly the same. So I should lose my middle term. So really what I'm doing is it's this thing squared minus this thing squared. So we would hope that our answer is going to be d squared minus 25, but let's check it. So d times d is going to be d squared. D times negative 5 minus 5d. 5 times d plus 5d, and 5 times negative 5 is minus 25. So see how they're going to cancel each other out and become 0? So I get d squared minus 25. So this is a special DOPS pattern. Okay, I hope that that makes sense, and I hope that you've got the hang of it. If you've got questions, please come and have a chat to me. Otherwise, this is your lovely acronym that you're going to remember forever. We're going to use it over and over and over again. If you have not heard this acronym before, burn it into your brain because you're going to want it all the time. FOIL. All right, good luck.